Good morning. Welcome to Math Natives. Do you speak mathematics? If you do, welcome home. If you don't, come and learn. So, what are we going to discuss today? Today's topic, we are going to uh, talk about, in our straight to the point lesson, whether or not 0 to the power of 0 is 1 or 0. So, we know that any number to the power of 0 is 1. And we also know by the rule of exponent that 0 to any power is 0. But what is 0 to the power of 0? In order for us to answer that question, we are going to use a mathematical concept called limit. Okay. And for us to use that, we are going to pick a function that model the situation right here. Right? We have 0 to the power of 0. So our function is x to the power of x, a number raised to the power of the same number. So that fits this situation that we are discussing here. So the way limits works is that we are going to get pick numbers that are getting closer and closer to 0, okay, and figure out if our answers are getting closer and closer to 1 or to 0. So if our answers are getting closer and closer to 1, that means that's our limit, and that would be uh, the answer to what we are looking to find. If it's getting closer to 0, then 0 would be the answer to the question that we are asking today. So we can proceed in two ways, using calculator or using graph. We are going to uh, do both ways. Right. So um, this work has already been done for us using a calculator. Okay. So basically, um, remember this concept is modeling uh, x to the power of x. All right. So we are using the limit concept, and we are going to be picking number, okay, right here, that are values that are getting closer and closer to 0, and we are going to see whether or not our answers that are on the right side right here, those answers are getting either closer and closer to 0 or to 1, right? So 1 to the power 1, that's 1. So if you go down 0.9 to the power of 0.9, so that's a 0.909. So you can see that as the values that we are entering are getting closer to 0, okay, the answers are also getting smaller and smaller. Right. And that is maybe up to this point. We can see that the value, it's true that they are getting smaller, but uh, that decrease is slowing down. Okay, so let's pick more values to figure out what is going on. Right. So we are going to go down further. Now, uh, at 0.3, okay, 0.3 to the power of 0.3, we can actually see that uh, we are going back up, right? 0 point, when x equals 0.4 to the power of 0.4, we we are at 0.693, but uh, when the value went down further, okay, at 0.3, this value is actually greater than this one right here. Okay, we thought we were going down towards 0, but now we are rising up again. And after this, okay, we can see that the value are getting bigger and bigger, right? So uh, we can tell, okay, that's okay. As we get really close to 0, 0.01, okay, to the power of 0.01, we have an answer that is closer and closer to 1. All right. As we get really, really, really close to 0, okay, we get our answers are getting increasingly closer to 1. Right. So that leads us to conclude that when we raise 0 to a power of 0, our answer is 1. Right. Okay. So that's using a calculator. Now let's use a graph to convey the same concept. I already graph the function for us right here. So x to the power x. So this is the graph that we see, right? So uh, we are still using the concept of limits, right? Now, so let's pick the values, right? Since this is a graph, we can clearly see what is going on, I guess, faster. So to show you that this is the graph of the function x to the power x, you can clearly see that 2, okay, x equal to raised to the power 2 give us an answer that is 4. Okay, you can see that that corresponds to y equal 4 right here, right? So now let's get closer and closer to 0. So as the value of x is getting closer to 0, with the calculator they started off at 1, right? X equal 1 to the power 1, okay, the answer there was 1. But as we get closer to 0, okay, you can see from uh, this point to this point, the values are getting smaller and smaller. But when we get to this lower point right here, the values start to increase more and more. And when we really get close to 0, now our answer is getting closer to 1. So that's why we can say that our limit is 1, right? And that help us to see graphically that 0 raised to a power 0 is 1, as we have confirmed using the calculator and the graph right here. I hope this make it clear. We are going to stop here and have a good day.